Let's do these couple examples that the last video skipped, and then we'll move on to the next page. So example 8 says convert each of the following into vertex form. So let's make sure we know what vertex form is. That's f of x is a times x minus h quantity squared plus k. Use the result to find the domain and range. And so algebraically just means completing the square. Complete the square. And then once we have the vertex, the domain and range are pretty easy. The domain for every parabola is negative infinity to infinity. So as long as this function's a parabola, we're good with that. But it's the range that depends on the vertex. So let's complete the square here. Now in these problems, when it says f of x equals, I can't like subtract the 5 to the other side the way we were when we were solving using completing the square. So in this case, I need just f of x equals on the left side, and I have to leave it by itself on that side to say that's the function. So instead, what we do is we add and subtract the same amount. All right, so I'm adding something and then subtracting something, so it's the same function. Really what we're doing is adding 0, but this way I get something that ideally here is a perfect square. And then plus or minus some other thing. Well, the other thing we're gonna call k. So let's complete the square. It's always b divided by 2. So here our b is 4. So it's 4 divided by 2 quantity squared. That'd be 2 squared, which is 4. So what I need to add and subtract are 4. And that gives me x plus 2 quantity squared. It's that b over 2 that goes here. And then if we look over here, what I have left is plus 1. And we still have f of x equals. The whole idea is that I didn't change that side of the formula. So now it's in vertex form. A is 1, there was no leading coefficient. So the vertex is the point. And with the h, it's always opposite sign. So it's negative 2. And with the k, it's the same side, so 1. Domain for every parabola is negative infinity to positive infinity. But the range, we got to make sure, depend on the sign of a. If a is positive, it's an upward facing parabola. If a was negative, it'd be reversed. So it goes from the y value of the vertex to infinity. All right, the lowest point is negative 2, 1. So the lowest y can be is 1, and then up to infinity. Let's try another one, and then we'll do a couple more with a leading coefficient. So again, we have to keep just plain old f of x equals. So we're going to do this trick where we add and subtract the same thing. So I'm adding something and subtracting the same something. And the minus 1's just hanging out there to combine with whatever we add and subtract. And what it is we're adding and subtracting is b divided by 2 quantity squared. So that'd be 5 over 2 squared, which is 25 over 4. Fractions are fine. We don't have to be afraid of fractions. With this one, the decimal is nice. It stops. It's not a repeating decimal, so you could put it in as a decimal. But let's just do 25 over 4. Some of us need practice with our fractions. So I'm going to add and subtract 25 over 4. The reason we did this is so that I could write f of x equals, and then it's a perfect square here. The perfect square is going to be x plus, because the plus here, and then b divided by 2 is 5 over 2. So if I used FOIL to multiply out x plus 5 over 2 squared, this is what we'd get. Not with these two pieces, but the x squared plus 5x plus 25 fourths. So now we just need to combine these two. In order to do that, you might want to think of the minus 1 as negative 4 over 4. and then minus 25 over 4. So that'd be minus 29/4. We have to get a common denominator, but 1 is just 4 over 4. So that means that this is our function in just a different form. So if we multiplied this all out, it would get right back to where we started with. This is standard form, this is vertex form. From vertex form, we can just look at it and know the vertex is negative 5 over 2, comma negative 29/4. Remember, with the H, it's the opposite sign. With the K, it's the same sign. Domain for a parabola is negative infinity to infinity. And then range. The A is positive, so it's upward facing. So it's the y value of the vertex to infinity. Negative 29/4 to infinity. Great. Hopefully those are making sense. Let's do a couple with a leading coefficient because they're similar, but there's just an extra step in there. So if we turn the page, example 10 definitely has some leading coefficients. Now, one thing we might see in part A here is that everything is divisible by 100. So you might feel like, well, we should just divide both sides by 100. The problem is I'm not solving this equation. I don't want f of x divided by 100 on the left side. So I can't just divide by 100, but I can factor out 100. We still want to maintain this f of x equals on the left side. But factoring out 100 works. I'd have x squared plus 6x, and then this is where we're going to add something to make it a perfect square. Now, instead of including the minus 1,400 in the factoring, I'm going to view that as just outside the parentheses. Because I need that, that k. Now here, we are going to have to subtract. We add something to complete the square, so I shouldn't put a plus there. I know it's going to be a subtraction, but what I'm going to end up subtracting is 100 times whatever's in this box. So I'm going to put 100 box there. All right, so I'm adding something here, and then I need to subtract 100 times whatever that something is. That's a little different than how the last video did it, so you can do it either way. I just like to remind myself right away that I'm going to need to multiply by 100. So let's do it. B divided by 2 is 6 divided by 2 squared is 3 squared, which is 9. So we're going to add 9 here, and so we're subtracting 100 times 9 over there. All right, so what we get, all I've done is rearrange a lot of pieces, right? We still have the same function that we're calling f of x. It's 100 times x plus 3 quantity squared. That's why I added the 9 to make that a perfect square. And then this is minus 1,400 minus 900. So that is a negative 2,300. All right, interesting. Let's look at the directions. It said find the vertex. So the vertex is the point negative 3 comma negative 2,300. The 100 out front is not part of the vertex. It determines how wide or narrow our parabola is. In this case, it's going to be a really narrow parabola. The domain of any right side up parabola or upside down is negative infinity to positive infinity. The range, well, this A is positive, so it's right side up, so it's going to be that y value to infinity. So negative 2,300 comma infinity. All right, well, that was part A. Let's see what part B does. Same thing, except now we have a negative coefficient, leading coefficient, I should call it. but that shouldn't make a huge difference. Let me just sort of do that. So same thing, f of x equals, and I'm going to factor out the -2 out of the first two terms. Now factoring out a negative is going to flip the sign. So it's going to be a positive x squared, but then a minus 12x. And then plus something. And just to make sure, multiply it out, right? Negative 2x squared plus 24x. So I did it right. And then we don't know what that is. So then I still have minus 66, but what I'm going to need to subtract to undo this addition is minus -2 times whatever this box is. And I'm totally out of room. But hopefully you can sort of follow along with that. Let's try it. All right, so what I need to add is negative b over 2. So negative, or not negative, it just is negative. B over 2 quantity squared is -6 squared is 36. So we have 36 here, and then 36 is going over here. Let me write it out a lot better here. So now I have f of x equals -2 times x squared minus 12x. And what I'm adding is 36. The minus 66 was part of the original problem. But now, because I added this 36, I need to subtract -2 times that same 36. I'm just rewriting it because I was all squished before. Right? Because this is the tricky part, right? That most people, I hope by now we've done enough completing the squares that you're like, oh yeah, b divided by 2 squared, 36. But it's that really what we added here is a negative 72. So I need to subtract a negative 72. I know, and there's all these negatives around. Let's see what this ends up being. F of x equals -2 times x minus 6 quantity squared. The minus comes from the 12. Then over here, I have -66 and then plus 72 because two negatives make a positive. So that just looks like plus 6. Yep. Okay. That is vertex form. It's definitely messier when there's a negative. You can always, remember, if you're worried about it, multiply it out, and you should get right back to where we started from. So the vertex of this is the point 6, 6. Because with x, it's the opposite sign. With y, it's the same sign. Domain is -infinity to infinity. And then range, ooh, here's where the range is a little different. Because the a is negative, a is less than 0, so our vertex is the highest point. So this parabola goes all the way down to -infinity in the y direction, and it goes up to y equals 6 is the highest value. All right, last one, and then we should be good for this section. It's a long section. There's a lot of stuff about completing the square that we've learned. This one says graph by algebraically determining its key features, then state the domain and range. All right, let's talk about key features. First is to notice that this is a polynomial of degree 2, so it's going to be a parabola. When we're talking about parabolas, we definitely need the vertex, but then we always include intercepts. So we want intercepts and the vertex when we're graphing these. All right, well, intercepts, let's start with the easiest one, which is the y-intercept. Y-intercept, all we do is plug in 0 into the function. F of 0 would be 0 minus 0 plus 6 is 6. So our y-intercept is the point 0, 6. Easy. X-intercepts, is when you set the function equal to 0. It's the y value that's 0. And it's not too bad if we can factor. If we can't, then it's either complete the square or quadratic formula. But I think this, let's see, does it factor? I don't think so. So let's actually, before I do this, let's get this in vertex form, because we're going to complete the square anyways to get in vertex form, and then the x-intercept's going to be easier. So, yeah, I'm actually, well, we can pause on that. Let's come back to it. So let's do completing the square, or vertex form, I'll call it. Okay, vertex form. So I have f of x equals x squared minus 2x, and then we're going to add something. The plus 6 from the original problem is still there, but then we need to subtract that same something. And by doing this, we should be able to get it into something squared. That's what completing the square and vertex form are about. So b divided by 2, quantity squared, negative 2 over 2 squared is negative 1 squared, which is 1. So I'm going to add 1 and subtract 1. So that makes it x minus 1 quantity squared plus 5. Luckily, there was no leading coefficient, which made it easier. So that means that the vertex is the point 1, 5. Now, the reason I paused on this x-intercept is because I can use this vertex form to find these x-intercepts maybe even a little easier. So what I can do is just say that this is x minus 1 quantity squared plus 5 equals 0. Because it didn't factor. If it factored, you know, I don't really need this completed the square one, but, you know, since I already have it down here, let's use it. All right, and again, if you multiplied it out, you'd get this same equation. Just want to make sure we're seeing that. So this would be x minus 1 quantity squared is negative 5. Wait a minute, I can't have something squared be negative, right? If I square rooted both sides, I'd get an imaginary number. So there are no x-intercepts. All right, well, those are some key features. Let's see if we can put these together in a graph. So we'll just try to draw some axes and see what we get. All right, first point is 0, 6. 1, 2, 3, 4, 5, 6. Here's the point, 0, 6, our y-intercept. Our other point is the point 1, 5. And I'm realizing I should have probably made each tick mark equal to 2, because all I'm getting here is a parabola up here. That's still a graph, it's just not maybe the best. You could always change what your axes are, but it's still a parabola. And that's why we didn't get any x-intercepts, right? Because it's up here and there's no place where it crosses the x-axis. Last step is domain and range. Domain, negative infinity to positive infinity. Range goes from the lowest y value is 5, and then it goes up to infinity.